Hello, my name is John Mason from Widener University. Welcome to my presentation on solvent-assisted mechanochemical synthesis of metal organic framework copper BTC. In this research, a study was done to determine the effectiveness of mechanochemical grinding for the preparation of microporous metal organic framework copper BTC from trismic acid and 3 different copper salts. The effects of parameters were changed, such as the different starting materials, the presence of solvent, and length of grinding. These were then viewed using XRD, FTIR, BET, and Langmuir analysis. First, we observed the role of starting materials. The starting materials that were used were trismic acid, that's the XRD is shown in A, copper nitrate trihydrate, which is shown in B, and copper acetate monohydrate, which is shown in C. After 30 minutes of grinding, the XRDs were then taken again. In D is our compound from copper nitrate trihydrate and trismic acid, and E is with copper acetate monohydrate and trismic acid. Comparing them to our reference standard that's seen in F, we see that the peaks in E, or the copper acetate copper BTC, represent the structure more closely than in D, where D is missing many of the peaks. Then we compared one reagent for a longer period of time for grinding. For copper nitrate trihydrate, we picked 30 minutes, 60 minutes, and 600 minutes to see if a longer time would produce copper BTC. It was found that even after 600 minutes, the copper BTC was not formed from trismic acid and copper nitrate. Then, the same procedure was followed with copper acetate monohydrate at 10 minutes, 20 minutes, 30 minutes, and 60 minutes. It was seen that in as little as 10 minutes, the effects of copper BTC were able to be seen, and after 20 minutes, we had copper BTC. And this effect continued at 30 and 60 minutes with copper acetate and trismic acid. Next, we looked at the roles of solvent using between no solvent in a anhydrous copper acetate to 400 microliters of 1-to-1 ethanol and water. It was found that when no solvent was added, it was not possible to form copper BTC. However, with as little as 50 microliters, copper BTC started to form. And after at least 100 microliters, we saw significantly more pronounced peaks in the copper BTC. This also was seen at 200 microliters and 400 microliters. In conclusion, it was found that copper acetate as a starting material worked better than copper nitrate in both product status and amount of yield. Water of hydration in the reactants was improved the copper BTC that was created. Small amounts of solvents also had a very large role and caused better pore sizes for hydrogen storage capacity. And overall, it was found that mechanochemical synthesis is a very quick and easier process than the traditional synthesis method of copper BTC. Thank you for listening, and for more information, please see our poster during the 2021 Spring ACS Convention in the on-demand poster section. Thank you. Have a great day.